Greetings friends. I hope you are all doing well. Today's video is about the fitting of a solar inverter. This is our first video, as I mentioned earlier, where we will discuss the basics of inverters. Often, technicians order solar inverter kits from us, but due to a lack of knowledge, they end up damaging the kit or making incorrect connections. This results in faults in the kit, and they call us saying the kit is not working. What happens is that they place the supply where the switch should be or swap the on-off switch and the connections, causing issues. So I decided to make a video to provide everyone with the necessary information about properly fitting a solar inverter. Starting the process first, we took an inverter body and installed check nuts for the board. We drilled holes for the coils and connectors, and for the fan, we installed a lock. We will explain things step by step as we proceed with the fitting. We are building a 7 kilowatt inverter in this video. We are installing a fan, and I will show you the components required and how much material is needed. First, observe how we install a high-speed fan using proper alignment. While attaching the fan, ensure the polarity negative and positive is correct to avoid reversing connections. Incorrect connections often cause the fan not to work, and this can sometimes damage the kit due to short circuits. Components installation for this 7 kilowatt inverter. We are using a kit with 6 330 UF capacitors. Additionally, we are adding a 450 volt, 4700 UF capacitor to handle the load, as high torque loads are common in 7 kilowatt inverters. We are also using double coils and a kit with 4 IGBTs. Let me explain the connections. The kit has solar input, positive and negative. The output section is where we will connect the load wires. There is a connector for the fan, 14 volts input. The switch is for on-off operations, and the supply input has its designated section. Assembly details: we use connectors for capacitors to avoid loose connections. Loose connections can cause sparks, leading to inverter failure or explosions under heavy loads. We have attached the LCD display, fan, and input-output PVC connectors. We also installed the coils and capacitors in a series connection. The solar input and AC output were correctly wired through connectors. Testing and final checks: once all connections are complete, we fitted the supply wires and installed the on-off switch. The fan wires were connected at their designated points. The entire setup was tested. Input voltage was measured at 323 DC volts. Output voltage was also verified. The display showed all necessary readings. Load testing was performed using a rod and a light, confirming the system worked flawlessly. In conclusion, we hope you enjoyed our video. In the next video, we will discuss common faults that occur during the fitting of kits and how to avoid them. Please subscribe to our channel and press the bell icon to stay updated with our new videos. Thank you, and see you in the next video. Goodbye.